Hello student, continue the topic eigenvalues and eigenvector. So here is example, find eigenvalues and eigenvectors of the matrix 2 0 minus 1 0 2 0 minus 1 0 2. Solution. In the first step we will find eigenvalue. So what is a given matrix? That given matrix you denote first as A. So matrix is 2 0 minus 1 row wise, 0 2 0 and a minus 1 0 2. So what is the characteristic equation of this matrix? As we know, the characteristic equation of matrix A is determinant of A minus lambda I equal to 0. So what is it? Determinant 2 minus lambda 0 minus 1 0 2 minus lambda 0 minus 1 0 2 minus lambda, and that is equal to 0. As we know, it is a 3 by 3 matrix. That is why it is a lambda cube formula minus s1 lambda square plus s2 lambda minus a determinant of A equal to 0. So what is s1? Addition of diagonal elements. So 2 plus 2 plus 2, that is equal to 6. And s2, minus of diagonal elements. So I am getting here first determinant 2 0 0 2, means minor of first diagonal element, minor of second diagonal element 2 minus 1 2. Note that here minor of this 2 is delete this row and this column. Minor of this 2 is delete this row and this column. So 2 minus 1 2. And minor of third element, third diagonal element is 2 0 0 2. So that is equal to 4 plus 3 plus 4, and that is equal to 11. What is the determinant of A? Determinant of A equal to 2 in bracket, it's a 4 minus 0 minus 0 minus 1 in bracket 0 minus minus plus 2. So I am getting 8 minus 2, that is equal to 6, and that is why the characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus a determinant of A equal to 0. Now find the factors or roots of this equation. So how to find? By synthetic division method. Coefficients you consider 1 minus 6, 11 minus 6. You try for 1. So here 1 into 1 I am getting here 1. So minus 5. So 1 into minus 5 I am getting minus 5. And 11 minus 5 addition is 6. So 6 into 1 6. So here I am getting 0. It means that this is the first root. So I am getting here lambda equal to 1. From the remaining I can write equation lambda square minus 5 lambda plus 6 equal to 0, and factors are lambda minus 3, lambda minus 2 equal to 0. So lambda equal to 3, 2. So what are the eigenvalues? So lambda equal to 1, 2 and 3. So these are the eigenvalues. So verify. So how to verify? What is the addition? 3 plus 2 plus 1, it is equal to 6, and the same as addition of diagonal element, that is also 6. 2 plus 2 plus 2, and product is equal to determinant. So what is the product of 1 2 3? So it is 6, and that is equal to determinant, means it's verified. So these are the eigenvalues of matrix A. Now step number 2, eigenvectors. Let x equal to xyz be eigenvector and consider matrix A minus lambda I into x equal to 0. So here eigenvalues are non-repeated, mean distinct eigenvalues 1, 2, 3. So one by one we can find. So what is this A minus lambda I? So here 2 minus lambda 0 minus 1 0, 2 minus lambda 0 minus 1 0 2 into x. X means eigenvector. So that is x y z, and that is equal to 0. Actually it is a null matrix. Now first value for lambda equal to 1 means eigenvalue lambda equal to 1. So you put here lambda equal to 1, here 1. Actually here should be 2 minus lambda, and here also 1. So therefore it gives the equations x plus 0y minus z equal to 0, 0x plus y plus 0z equal to 0, and minus x plus 0y plus z equal to 0. Note that here when we put lambda equal to 1, so multiply these two matrices and we'll get these three equations. Now by Kramer's rule, x upon determinant coefficients of y and z. So you consider last two equations. So 1 0 0 1 minus y upon determinant 0 0 minus 1 1 and z upon 0 1 minus 1 0, and that is why I am getting x upon, it is a 1 minus y upon, it's a 0, and z upon 0 minus minus plus 1. So therefore our x1 means first vector is 1 0 1. So one can write here corresponding lambda value, that is 1. So now lambda equal to 2. You put in this equation lambda equal to 2. For lambda equal to 2 means second eigenvalue. So now I am getting when lambda equal to 2, it is a 0x plus 0y minus z equal to 0, 0x plus 0y plus 0z equal to 0, and minus 1x plus 0y plus 0z equal to 0. So by Kramer's rule, you find the values of x, y, z. But note that here second equation contains all 0, means this is not equation there. And that is why first and third, by using Kramer's rule, I can consider x upon determinant of 0 minus 1 0 0 minus y upon 0 minus 1 minus 1 0 and z upon determinant 0 0 and minus 1 0, and therefore the values of x, y, z are x corresponding, that is 0, minus y upon 0 minus 1 and z upon 0 0. So what is x2? If we see here 0, here minus minus plus 1 0. So I am getting second vector is 0 1 0. One can write here corresponding lambda equal to 2. Similarly, for lambda equal to third eigenvalue, which is nothing but 3. Again you put here lambda equal to 3, 3, 3. So here we'll get 3 equations, that is a minus x plus 0y minus z equal to 0, 0x minus y plus 0z equal to 0 and minus x plus 0y minus z equal to 0. And that is why x upon determinant from last two equations I am getting minus 1, 0, 0 minus 1 minus y upon determinant 0, 0 minus 1 minus 1 and z upon determinant 0 minus 1 minus 1 0. So corresponding values, so I am getting x upon minus minus plus 1 minus y upon 0 minus 0, that is 0, and z upon 0 minus 1. So that is why x3 equal to I am getting 1, 0 minus 1. So which is corresponding to third eigenvalue, which is nothing but 3. So these are 3 eigenvectors corresponding to eigenvalues. So x1, here x2 and here x3. So which is your required answer. Now next example, find eigenvalues and eigenvectors of the matrix 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Solution. Step number 1, which is for eigenvalues. Given matrix you denote by A, it is 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. The characteristic equation is determinant of A minus lambda I equal to 0, and that is why I am getting here determinant 6 minus lambda minus 2 2 minus 2 3 minus lambda minus 1 2 minus 1 3 minus lambda, and that is equal to 0. So what is the formula for this? We know the formula. It is a lambda cube minus s1 lambda square plus s2 lambda minus a determinant of A equal to 0. So what is s1 there? S1 equal to summation of diagonal element. So I am getting here 6 plus 3 plus 3, that is equal to 12. What about s2? So what is s2 here? Minus of diagonal elements. So I am getting here 3 minus 1 3 plus minor of second diagonal element, it is a 6 2 2 3 plus determinant of minor of third diagonal element. I am getting here 6 minus 2 3, and that is equal to, so see there, diagonal of first element, delete this row, this column. So I am getting this 3 minus 1 3. Diagonal of second element, delete this row, this column. So 6 2 2 3, and delete this row and this column for the third diagonal element. So 6 minus 2 3. So that is equal to, I am getting 9 minus 1, it is 8. 18 minus 4, it's a 14. And 18 minus 4, it's a 14. And that is equal to 36. And determinant of A, that is equal to 6 in bracket 9 minus 1, it is a 8 minus minus plus 2 in bracket minus 6 plus 2 minus 4 and a plus 2 in bracket 2 minus 6 minus 4. So that is equal to 48 minus 8 minus 8, and that is 32. And therefore the characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus a determinant of A equal to 0. So what are the roots of this characteristic equations? We can find by synthetic division method. Coefficients 1, minus 12, 36 and minus 32. So first you try for 1. So 1 here, 1 into 1. So I am getting minus 11. 1 into minus 11 here. So I am getting here addition of 36 and minus 11. 25. So 25 I am not getting 0 here. So 1 is not root. Similarly you try for minus 1. So 1, minus 12, 36 and minus 32. So minus 1. So this 1 as it is. So minus 1 into 1. I am getting minus 1. So minus 13. So minus 1 into minus 13. I am getting here 30. And it is a 9 and 4. It's a minus 49. Whatever there but not 0. Now you try for 2. So coefficients again 1, minus 12, 36 and minus 32. Now try for 2. So 1 as it is. So 2 into 1 it is a 2. So minus 10. 2 into minus 10 minus 20. So 6 and 1. So it is a plus 32. So I am getting 0 here. It means that lambda equal to 2. First value is lambda equal to 2. So here I can write lambda equal to 2, and from the remaining lambda square minus 10 lambda plus 16 equal to 0. So factors are lambda minus 8, lambda minus 2. So therefore roots are 8 and 2. So finally the roots are 8, 2, 2. So here one can write 2 to 8, but this is non-repeat. That is why I am going to write initially it. So these are the eigenvalues. So let's verify how. What is the addition? 8 plus 2 plus 2, it is a 12, and that is nothing but the addition of diagonal element, and which is nothing but 6 plus 3 plus 3, it is 12. Correct. Then determinant of A equal to product of these eigenvalues. So 8 into 2 into 2. So it is 32, and determinant also 32. Means these are the eigenvalues of matrix A or given matrix A. Now what are the eigenvectors? But note here repeated eigenvalues are there. So one is non-repeat, that is 8. So for that it is a routine method. So just find here eigenvector. Now the step number 2, eigenvectors. So let you consider x equal to x, y, z be eigenvector. Consider matrix A minus lambda I into x equal to 0. So what is this matrix A minus lambda I? It is 6 minus lambda minus 2, 2 minus 2, 3 minus lambda minus 1, 2 minus 1, 3 minus lambda. And here eigenvector x, y, z, and that is equal to 0. So first non-repeat eigenvalue, that is for lambda equal to 8. So put this lambda here. So we will get here 3 equations: minus 2x minus 2y plus 2z equal to 0, minus 2x, so 3 minus 8, that is minus 5y minus z equal to 0, and 2x minus y minus 5z equal to 0. By Cramer's rule, you can find the values of x, y, z. So by last two equations, by Cramer's rule, I am getting x upon determinant minus 5 minus 1 minus 1 minus 5 equal to minus y upon determinant minus 2 minus 1 2 minus 5 and z upon determinant minus 2 minus 5 2 minus 1. So therefore I am getting the values x upon, it is a minus 5 minus 5, it is 25 minus 1, that is a 24 minus y upon 10 plus 2, it is a 12 and z upon 2 plus 10, it is a 12. And therefore if we consider the x1, corresponding x1, if we divide by 12, so I am getting x1 equal to 2 minus 1 1 corresponding to lambda equal to 8. So for next eigenvalue which is repeat, so lambda equal to 2 comma 2, repeated eigenvalues. So what to do? First you find the rank of matrix A minus lambda I. Just recall the things. If repeated eigenvalues, so find the rank of A minus lambda for that particular lambda, then n minus r eigenvectors are possible. When n equal to number of unknowns and r equal to rank, then n minus r eigenvectors are possible. If only one vector, then find it directly. If two vectors, then we have to check whether the given matrix is symmetric or unsymmetric. So what is the rank of A minus lambda? First you write this for lambda equal to 2. So what is this matrix? So I am getting here 4 minus 2, 2 minus 2, 3 minus 2, it is 1 minus 1, then 2 minus 1, 3 minus 2, it is 1. First find the rank of this by echelon form. So what is that? Operate R1 divided by 2. So I am getting equivalence matrix is 2 minus 1, 1 minus 2, 1 minus 1, 2 minus 1, 1. And here operate R2 plus R1 and R3 minus R1. So equivalence matrix is what? I am getting 2 minus 1, 1, 0, 0, 0, 0, 0, 0. So what is the rank of this matrix? So rank of this matrix A minus lambda, if we denote by R, that is equal to 1. And n means number of unknowns here x, y, z. So 3. So what is n minus r? So I am getting here n minus r equal to 3 minus 1, that is a 2. So therefore 2 eigenvectors are possible or exist, you can say. Now recall the things again. So you must have the theoretical part, how to find if repeated eigenvalues. So what is it? So here, if there are two vectors, then we have to check A equal to A transpose or A is not equal to A transpose. You see here, given matrix 6 minus 2, 2, minus 2, 3, minus 1. So what is A transpose? If we write here A transpose, I am getting the first row 6 minus 2, 2. So 6 minus 2, 2. Second row minus 2, 3, minus 1. Third row 2, minus 1, 3. And we'll get the same. It means that A equal to A transpose here. So here A equal to A transpose. It means that given matrix is symmetric. Then find first eigenvector. Next eigenvector you consider x3 equal to L m n and x1 into x3 transpose equal to 0, x2 into x3 transpose equal to 0 and find L m n. So let's consider. So by this method, see there, from the last matrix you can find, by this matrix you will get one equation. So that equation is nothing but 2x minus y plus z equal to 0. And here you find x2, means second eigenvector. So here one equation and three unknowns. So 1 and 3. So what is difference? 2. So we have to put two variable equal to some constant. So simple constant I will put here. Put z equal to 0. So what is that? I am getting here 2x equal to y when we put z equal to 0. And that is why I am getting x2 equal to second eigenvector. So z equal to 0, it is fixed. And here when we put x equal to 1, so I am getting y equal to 2. So 1, 2, 0. So corresponding third eigenvector I am going to consider because it is a symmetric matrix, and we know in the symmetric matrix eigenvectors are orthogonal, and that is why I am going to consider L m n and solve x1 x3 transpose equal to 0 and x2 x3 transpose equal to 0. So what is x1, which you know, you already have corresponding to first eigen value 2 minus 1 1, and x3 transpose means like this L m n equal to 0, and second x2 1 2 0. Note that it is not necessary here to consider z equal to 0 because we can put any value. One may consider here 1. So corresponding values of y and x we can find. But for simplicity I am taking here z equal to 0. So automatically corresponding x3 may change in that case. So here L m n. So I am getting corresponding two equations. So it is a 2L minus m plus n equal to 0. Then L plus 2m plus 0n equal to 0. And by Kramer's rule, I can find the values of L m n. It is a minus 1, 1, 2, 0. Second is minus m always. Then 2, 1, 1, 0. And n here 2 minus 1, 1, 2. So what are the values of L m n? So I am getting here L upon 0 minus 2 minus m upon 0 minus 1 and n upon 4 plus 1, it is a 5. So what is x3 there? It is L m n. You consider least value. So I am getting minus 2, 1 and 5. So this is corresponding to lambda equal to 2. So we have two eigenvectors corresponding to lambda equal to 2. So first, second and third eigenvalues are there. So which is your required answer. Now next example, find eigenvalues and eigenvectors of the matrix minus 9, 4, 4, minus 8, 3, 4 and minus 16, 8, 7. So solution for that. Step number 1. Given matrix you denote by A minus 9, 4, 4, minus 8, 3, 4 and minus 16, 8, 7. The characteristic equation is, so what is it? It is the determinant of A minus lambda I equal to 0. And therefore, I am getting here a determinant of minus 9 minus lambda, 4, 4, minus 8, 3 minus lambda, 4 and minus 16, 8, 7 minus lambda, that is equal to 0. So as we know, the formula for this is a lambda cube minus S1 lambda square plus S2 lambda minus a determinant of A equal to 0. So what is S1? Addition of diagonal element minus 9 plus 3 plus 7, that is equal to 1. S2 minus of diagonal element, it is of first 3, 4, 8, 7 plus minus 9, 4, minus 16 and 7 plus determinant minus 9, 4, minus 8, 3. See there, the minors of diagonal elements. So minor of this minus 9 is, delete this row and this column, 3, 4, 8, 7. Minor of second diagonal element, it is minus 9, 4, minus 16, 7. Minor of third diagonal element is minus 9, 4, minus 8, 3. So what is the value for this? That is equal to, so you can use your calculator. I am getting here minus 11 plus 1 plus 5 and that is equal to minus 5. Now find the determinant value. The determinant of A equal to minus 9 into 21 minus 32 minus 4 into 56 plus 64 and a plus 4 into minus 64 plus 48. So I am getting here minus 9 into minus 11 minus 4 into 8 and a plus 4 into minus 16. So that is equal to 99 minus 32 minus 64, and that is equal to, it is 3. And therefore the characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus a determinant of A equal to 0. So find the roots of this characteristic equation which gives us the eigenvalue. So how? By synthetic division. Here 1, minus 1, minus 5, minus 3. So you try for 1, then minus 1, if not. So I am getting here 1, 1 into 1 here, it is 0, 1 into 0 here 0, minus 5 and here minus 5, which is not equal to 0. Try for next value, which is minus 1. So again minus 1, 1, minus 1, minus 5, minus 3. Here 1, minus 1 into 1, it is minus 1. Addition is minus 2, plus 2. Addition is minus 3. multiplication it is 3 and here I am getting 0. It means that lambda equal to minus 1 there. And from the remaining it is a lambda square minus 2 lambda minus 3 equal to 0. So factors are lambda minus 3 and lambda plus 1. Therefore, I am getting the lambda equal to 3 and minus 1. Finally, I am getting lambda equal to 3, minus 1 and minus 1 are the eigenvalues. So, verify. So, what is the addition? 3 minus 1, it is 1. So, addition of diagonal element is 7 plus 3 minus 9, it is 1. And product is 3 into minus 1 into minus 1, it is a 3. And it is nothing but determinant. Yes. So, therefore, eigenvalues verified. So, these are the eigenvalues of given matrix A. Now, the eigenvector. So, here non-repeat value is 3. So, for that it is a routine method, and for minus 1 means repeated. How to find eigenvector? Let's see. But before to that, you just find eigenvector for first non-repeat value. So, step number 2. So, eigenvectors. Let x equal to x, y, z be eigenvector, and consider here matrix A minus lambda into x equal to 0. Here minus 9 minus lambda, 4, 4, minus 8, 3 minus lambda, 4, and minus 16, 8, 7 minus lambda into x. X is what here? It is x, y, z equal to 0. So, first eigenvalue, that is 3, which is non-repeat. So, by routine method for lambda equal to 3, you substitute there and you will get 3 equations. So, how? So, minus 3 minus 9, it is a minus 12x plus 4y plus 4z equal to 0, minus 8x, 3 minus 3, it is a 0y plus 4z equal to 0, and minus 16x plus 8y, and 7 minus 3, it is a 4z, and that is equal to 0. So, by Kramer's rule, I am getting x upon determinant by last two equations 0, 4, 8, 4, minus y upon determinant minus 8, 4, minus 16 and 4, and z upon minus 8, 0, minus 16, 8. So, therefore, the values of x, y, z are. So, this implies x upon 0 minus 32 minus y upon minus 32 plus 64. So, it is a plus 32, and z upon minus 64. So, you can see here minus 32, y is minus 32 and z is minus 64. If we divide by minus 32, so I am getting here x1 equal to first eigenvector is equal to 1, 1, 2, corresponding to lambda equal to 3. Now, next eigenvalue which is repeated minus 1, minus 1 for lambda equal to minus 1, minus 1. So, we know the method. If repeated, first you find the rank of A minus lambda I for lambda equal to this repeated value minus 1. So, what is that matrix now? So, matrix A minus lambda I for this lambda equal to minus 1. So, minus 9 minus minus plus 1, it is a minus 8, 4, 4, minus 8, 3 minus minus plus 1, so 4, 4 and minus 16, 8 and 7 minus minus plus 1, so I'm getting 8. So minus 8 and minus 16, these are multiples, so need not to obtain 1 there. So operate R2 minus R1 and R3 minus 2 times R1. So equivalence matrix is now minus 8, 4, 4, 0, 0, 0. Here also 0, 0 and 0. So what is the rank of this matrix? So rank of A minus lambda I, if we denote, it is by R, so I am getting it is 1. And n, number of unknowns, that is 3, x, y, z here. So this implies that n minus r vectors means 3 minus 1, that is 2 eigenvectors are possible. Therefore 2 eigenvectors are possible, or you can say exist. So how to find? So very simple way, here given matrix is symmetric or unsymmetric. So check here, given matrix is symmetric or unsymmetric. First row is minus 9, 4, 4 and first column is not minus 9, 4, 4. It means that given matrix is not symmetric. So therefore here A is not equal to A transpose. Just recall the theory part. Find the rank, and if two vectors are possible, you check A equal to A transpose and A is not equal to A transpose. In this case, we will get one equation, put Z equal to 0, find xy, put y equal to 0, find xz. Means what? Means from the last matrix, I am getting one single equation, which is nothing but minus 8x plus 4y plus 4z equal to 0. So to find two eigenvectors, so note that put z equal to 0. What implies? Minus 8x plus 4y equal to 0. And this implies 8x equal to 4y, means here 2x equal to y, and therefore I will consider x2 vector, as we consider here z is 0. Now put value of x is 1, so I am getting y is 2, corresponding to lambda equal to minus 1. And if we put here y equal to 0, so what we get? Here minus 8x plus 4z equal to 0, and I am getting here 2x equal to z, and therefore I will get x3 equal to, as y equal to 0, you put z equal to any value, so I will get x. So here x equal to, I will consider 1, so z equal to 2, corresponding to lambda equal to minus 1. So note that here 3 eigenvectors, that is a 1, this 2 and 3, which is your required answer. So consider the next example. Find eigenvalues and eigenvectors of the matrix minus 3, minus 7, minus 5, 2, 4, 3, 1, 2, 2. So solution here, given matrix is, you denote by A. So matrix A equal to minus 3, minus 7, minus 5, 2, 4, 3, 1, 2, 2. What is the characteristic equation of this matrix A? It is the determinant of A minus lambda equal to 0. And therefore, I am getting determinant of A minus lambda is minus 3 minus lambda, minus 7, minus 5, 2, 4 minus lambda, 3, 1, 2, 2 minus lambda equal to 0. This implies that, as we know, the direct formula for this lambda cube minus s1 lambda square plus s2 lambda minus determinant of A equal to 0. So what is s1? It is a summation of diagonal element minus 3, 4, 2, and that is equal to 3. What about S2? So S2 is nothing but a minor of diagonal element. So delete first diagonal element, delete this row and this column. So I am getting 4, 3, 2, 2. For second diagonal element, -3, -5, 1, 2. And third diagonal element, -3, -7, 2, 4. So I am getting that is equal to 2 minus 1 plus 2, that is equal to 3. And now the determinant of A equal to. So what is the determinant of A? That is equal to -3 into 2 plus 7 into 1 minus 5 into 0. So that is -6 plus 7 minus 0. That is 1. You know how to find determinant of A. And now I am getting the characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus a determinant of A equal to 0. And this is a well-known cubic equation, which is nothing but lambda minus 1 cube equal to 0. This implies that lambda equal to 1, 1, 1. So here eigenvalues are repeated. So all three repeated, same 1, 1, 1. So verify these eigenvalues. How? That is addition 1 plus 1 plus 1, and that is nothing but addition of diagonal elements. So -3 plus 4 plus 2, it is 3, and multiplication 1 into 1 into 1, that is 1. It is equal to determinant. So verified. So these are the eigenvalues. So lambda equal to 1, 1, 1 are the eigenvalues of given matrix A. Now the step number 2, eigenvectors. Let x equal to x, y, z be eigenvectors. Consider here matrix A minus lambda I into x equal to 0. So what is this A minus lambda I here? So here -3 minus lambda, -7 minus 5, then 2, 4 minus lambda, 3, and 1, 2, 2 minus lambda into x. So what is x here? X, y, z. Equal to 0. So here for eigenvalue which is repeated 1, 1, 1. So what is the method? First find the rank of matrix A minus lambda I when lambda equal to 1. So I am getting here A minus lambda I, this matrix when lambda equal to 1. So matrix is -3 minus 1 minus 4 -7 minus 5 2 4 minus 1, it is a 3, it is a 3, it is 1 2 2 minus 1, it is 1. So now we want to find rank of this. So operate, you know the echelon form, R1 3 means interchange first and third row. So I am getting here 1 2 1 2 3 3 and -4 -7 -5. So operate R2 minus 2 R1 and R3 plus 4 R1. So I am getting equivalence matrix is 1 2 1, 2 minus 2 it is 0, 3 minus 4 it is -1, and 3 minus 2 it is 1. Here 0 minus 4 plus 4 -7 plus 8 it is 1, and -5 plus 4 it is -1. Now diagonal position, and after that below that 0. So operate R3 plus R2. So I am getting equivalence matrix is 1 2 1, 0 minus 1 1, and addition is 0 0 and finally 0. So what is the rank? This is echelon form, and therefore rank of matrix A minus lambda I, if we denote it is by R, that is equal to 2. So for lambda equal to 1, 1, 1, which is repeated, here rank is 2, and n means number of unknowns, which is nothing but 3 here, x, y, z, and this implies that what is n minus r? So 3 minus 2 means 1. So only one vector is possible. That is, eigenvector is possible. So from last matrix I am getting x plus 2y plus z equal to 0, 0x minus y plus z equal to 0. By Kramer's rule, you can find here x upon determinant of 2, 1, minus 1, 1. That is equal to minus y upon. So definitely here 0x. So I am getting here 1, 1, 0, 1. And z equal to, or z upon, that is 1, 2, 0, minus 1. So what are the values of x, y, z? So x upon, it is a 2 plus 1, it is a 3, minus y upon, it is 1, and z upon, it is a minus 1. So here 3 minus 1 minus 1. So actually I am going to consider here maximum positive, that is why minus 3, 1, 1, which is corresponding to lambda equal to 1. So note that in this case only one eigenvector is possible. So this is your required answer.